Hi, this is Babak. In this video I'm going to solve the following problem for you. This problem is a problem in linear algebra on the topic of cross product of vectors. Let me read the problem for you first. Let u and v be non-zero vectors such that the norm of u cross v minus u dot v is equal to 0. Determine the angle between these vectors minus square root of 2 norm of v multiplied by vector u, norm of v multiplied by vector u plus norm of u multiplied by vector v. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do it correctly, the answer that you will get is 157.5 degrees. Okay, now let me solve the problem for you. So I will use this piece of information to get some information about the angle between vectors u and v, and then using that and the argument that I am going to discuss about that, I can find the angle between these two vectors. Okay, so how should I do that? This is my assumption that the norm of vector u cross v is equal to u dot v. Yes, I am moving minus u dot v to the other side, but you know the formula for the norm of cross product. It's the norm of the first vector multiplied by the norm of the second vector multiplied by the sine of the angle between them. So I am assuming that theta, the angle between vectors u and v. Okay, so on the right hand side you know the formula for the dot product. It is norm of u, norm of v, but cosine of the angle between them. It is mentioned in the problem that these vectors are non-zero vectors, so these are non-zero numbers, so I can safely divide both sides by this non-zero number. I can safely divide by this non-zero number, and what I get is sine theta is equal to cosine theta. And on the other hand, we know that the angle between two vectors is somewhere between 0 degrees up to 180 degrees by definition inclusive. So from here, I realize that there is only one angle whose sine is equal to its cosine, and it lies between 0 and 180, and that is the famous angle 45 degrees. So we realize the angle between these two vectors is 45 degrees. Okay, but now let us have an understanding about these vectors. So if you see here, I don't know the exact value of the norm of v, but I know that it's a positive number. When I multiply it by minus the square root of 2, this becomes a negative number, and I am multiplying a negative number by vector u. So what happens? It would be a vector parallel to u, but in the opposite direction, whose length is equal to the absolute value of this number multiplied by the length of u. But here you will see, in the reason that I am clarifying right now, you don't need to know about the lengths. Okay, so what I am saying is that let us, for example, sketch a picture for ourselves. So for example, let us assume that this vector is the non-zero vector. I will call it u. Yes, so we realize that this vector is a vector parallel to u, but in the opposite direction, because this number is a negative number. Of course, I don't know the exact size, but I can imagine that, for example, that vector would be something like this. Okay, so the only problem about my sketching is that I really don't know the ratio exactly between this green vector and the blue vector. But as far as finding the angle is concerned, you will see that it is not important at all. So let me just imagine that this vector is my minus square root of 2 norm of v and then norm of u, so multiplied by vector u. Okay, so might be this vector is longer than u or shorter than u, we don't care. And I have another vector, that is vector v. So let me draw vector v somewhere here, for example. But we know that the angle between these two vectors, let me make it a little bit shorter here, but we know the angle between these two vectors u and v is 45 degrees. So assume that this angle is 45 degrees here based on that. But now let us have an understanding of this vector. Let us measure, let us calculate, or I don't know, let us compare the length of this component and that component. Okay, so let us do this. I want to know the length of the first part, meaning this, yes? But you know that the length, so let me write the formula here for you. If I have a number lambda multiplied by vector a, and I want to find the length of this vector, I need to find the absolute value of my number multiplied by the norm of my vector, yes? So here this is playing the role of this lambda here. So this becomes absolute value of the number, which is norm of vector, multiplied by the norm of my vector. But I don't need absolute value because norm of a vector is positive here, so this becomes norm of v multiplied norm of u, yes? So this is a number, yes, and I got that. I will do the same thing for the other component, so I will determine the length of the second component, but exactly according to the same formula, it becomes absolute value of norm of u multiplied by the norm of v. But again, I don't need absolute value because it's positive, and it becomes this. Okay, now you can compare this one and that one. Norm of u and norm of v are numbers, so it doesn't matter if I multiply this number by that number or this number by that number. So it means that these two are the same. So what I realized that these two vectors have the same length. But one of them is a positive multiple of u, so it lies on u in the same direction, but might be longer than u or shorter than u. So let us just decide about one of them. For example, let me assume that this is shorter and this is the vector that you have. Of course, it might be a very bad picture, but as I tell you, we don't need to know about the correct lengths here. So assume that this is your vector, but when I want to draw this vector, this is a positive multiple of v, so it should lie on v and in the same direction, but because of this calculation, then I have to respect that this one has exactly the same length as this one. That is crucial here. So I will draw another vector here, try to make it the same length, and this would be the vector u, norm of u multiplied by vector v. Okay, but now I want to add these two red vectors. So I construct a parallelogram on that. Yes. But this, and then if I add them, this is the vector that I am looking for. Yes. So this vector is norm of u v plus norm of v u. But because this parallelogram, if you look here, the length of these two adjacent sides are the same, so it means that this is not actually a parallelogram. We can be more specific than that. It is actually a rhombus. And we know that in a rhombus, the diagonal bisects the angle between two vectors. Okay, so the angle between these two blue vectors which is exactly the angle between these two vectors, the red vectors, is equal to 45. So if I ask you what the angle here is, you would say it is half of the 45, which is 22.5 degrees. Okay? But you are supposed to find the angle between this vector here, you see, and this vector, which is in this direction, and they have been drawn from the same point. So the angle between these two vectors is this vector. But of course, if I ask you how much is this angle is 180 degrees minus 45 degrees, which is 135 degrees. So now if I ask you what is the angle here from this vector to this vector, I need to add these two numbers. So the question mark that we are looking for is 135 degrees plus 22.5 degrees. So this becomes 157.5 degrees. Yes? I think this is the easiest way to solve this problem. Of course, you can use the dot product between these two vectors, but then you have to do a lot of calculations. I also recommend you, if you are interested in these kinds of problems, try to give it a try yourself in that method, using the inner product between these two vectors. But I would say this is the easiest way. And of course, I'm just mentioning again, I don't know anything about these sizes. Might be this is completely wrong from size point of view, but from angle point of view, everything is correct. I will put the link to the PDF file of these notes below this video. I hope this video was useful for you. Until the next video, be safe and goodbye. Thank you.